let's open a new project, and there is a blank space here, and then you can go for source, voltage source, and I'm going for pulse here. So I'm going to show an example. So how a square wave is connected. So let's go for pulse wave here, and then in that we're going to just make a simple circuit, the resistor, and I'm going to connect all these, and you can see a simple ground here, and let's connect it all together, and we have a simple circuit here. And then let's select, and I'm going to give V1 and V2. It is similar to on and off time. So I'm going to give off time as 0, and V1 is equal to 5. And the time to delay is, I'm going to give 0. And a rising time, so this is basically the time taken to rise up. So I'm going to basically select it and give it a number here. I'm going to give 0 here, and falling time I'm going to give it, let's give some nanoseconds if you want, but I'm going to give 0. And we have PW and PR, and let's give it a value here. So let's say we are going to give nanoseconds or so, and I'm giving it 1 nanoseconds, and PR, so give it 2 milliseconds, and then we are going to connect everything. And so for new simulation, we need to give a simulation profile, general circuit, and then let's connect the probe. I'm giving the probe here, and after that I'm giving it some few seconds. So for a running time, I'm going to give it 100 milliseconds if we want, but as the time period is slow here, I'm going to give 10 milliseconds. So, and then let's run this, and after that you can see profile is rising here. So let's connect the probe, and I'm going to give the probe in within the resistor and the voltage source, and then let's see simulation profile is created, and you can see that a waveform is created. I'm going to maximize the screen here. So after that you can see that there is a wave, a PWM wave. It's a square wave. You can see that with on and off time, and this is a basic pulse circuit with P pulse. So let's create the circuit. Let's for R-2R, which is a DAC, which basically converts digital data to analog data. If you give it a digital digit like 100, which is equal to 4, it will give you an equivalent voltage, which is 4. So let's give operational amplifier here, and you can see the internal voltage is already given here, and you don't need to give it externally, and there's an internal connection here. So let's give that, and after that we can search for resistors. Basically we need a set of resistors. So first you can see I'm giving resistors, and you can see the names already given here, R1, R2 and such. So let's give all the resistors. You can search resistors in place, which is basically on top, and I'm going to place all the resistors, and see we have 7 resistors here, and let's connect, and the circuit diagram is given in your book, so you can follow it. And then we need to invert it. There are two ways we can manually invert or rotate it, or you can go for mirror vertically. And let's connect the negative side here, and then let's connect all these resistors together with wire, and you need to check whether everything is correct here. Every resistors are connected together, not hanging or not floating. If there is an error, it can be checked in netlist. And you can see that the connections have been given, and I forgot to give a resistor there. Resistor between the negative side and the output side, and you can see that the pulse voltage source has been connected here, and we are given V1 as 0, V2 as 1, delay time as 0, rise time as 1 nanoseconds, and falling time 1 nanoseconds, PWM is 5, and PER is 10 milliseconds, and another probe is placed in output. And you can see a wave has been generated. So if you keep resistors in each of the ground or the voltage source, so basically there is a switch there, it acts as a switch. So if you are going to give some other digits, it depends on how the connection has been given. And for we have given 100, the MSB is on right side and LSB on the left side. For that, our circuit has given the output with square waves here, and you can see that in the video, in the screen itself. And that is all for our DAC. So DAC basically converts digital to analog, and the digital data equivalent voltage is given as output, and is very useful for signal processing and such. And that's all. Thank you.